Hi, in this video we're going to see a couple of ways for dividing, and these are just some strategies that you can use for division. First we're going to start off with Hangman division, then Big 7. We're going to move on to open arrays, modeling, and finally just a fun acronym. This video is not suggested to be used for students alone. I would definitely use this as a teacher, as an educator, as a parent working with children, but I would not use this to just show children because I really do think that they need some time with each strategy, find out which one works best for them. But in this short video, it would just be too much information in too short of a time. That said, let's begin with the Hangman version of division. So Hangman gets its name from how it looks, the board game Hangman, where you do have your little buddy that you can hang here. So if we're looking at some numbers that we can divide, I have 6 being divided into 686. I really am looking at this for what it is, and it's just partial quotient. So the partial quotient that we're looking to have get us closest to this number. But again, it doesn't have to be the closest. So most students might know 6 times 100 is 600. And that's a great way to start with a base 10 number. I'm going to subtract. I then use another base 10 number, but if they don't know another base 10 number, they might know 6 times 5 is 30. Subtract. 6 times 5 again, 30. It gets us closer. So now we're at 26. You might have to adjust your Hangman stand. Again, that's not important. And then I know 5 times 6 is too much. I know 5 times 6 is going to be over what we need. So 4 times 6 is 24. We subtract 2 is what's left over because I cannot divide 6 into 2. I take all of these values, I add them up. 100 plus 5, another 5 is 10, and 4. So we have 114 with a remainder of 2. And again, this might not be appropriate for all students, more for perhaps year 4 and up, if you have introduced remainders. So that's our Hangman version. The Big 7 is simply that, a large 7. As you see, it does not differ much from the Hangman version, and it is partial quotients again, but I try to have them write out and build some confidence with some multiplication skills that they know. So they're probably very good with, if we are doing 686 divided by 6 again, I can have students write down 6 times 1, 6 times 2, 6 times 3, basic facts that they should know. And then I'm going to build on that. They might know, again, those base 10 numbers. So 6 times 10, 6 times 20, 6 times 30. They might even see this relationship, 6 times 3. We're annexing a 0. And then we start putting our products. Again, just the first 3 might be enough. Large dividends. So I might go on to my hundreds. 6 times 100, 6 times 200. And once we start to do this, I might even stop here because we know, wow, any more, I'm going to go way over our dividend. So I might stop right there. And now I'm going to use these facts to help us. So to get us closest to, where here I didn't need to get closest to, I just wanted to get closer. Here I want to get closest to, but I don't need to. I can use some smaller values as well. But I see here 6 times 100 is 600. Subtract 86. Getting close to 86, 6 times 10 is 60. Subtract. To get closest to 26 without going over, 6 times 3 is 18. Subtract. 6 times 1 is 6. We add up our values, 114 with a remainder of 2. So again, very similar, just different, and maybe different enough that you find a child likes one over the other. Moving on to open arrays. So if you have been introducing arrays to students, we can have an open array. I might have a word problem where we're talking about 112 students, and they need to be split up or divided. And I'll always try to use those terms, split up, divided equally. We're trying to always go for equal, but we might not always have equal. And that's where we have our remainders. 112 students into 8 teams. How many students on each team? So an open array, I know I'm going to have my 8. Here's our array, and it's 8 times something. We want to get to 112. Well, again, very good fact. 6 times any 10, or now here we're using 8 times 10, or any base 10 number. 8 times 10 is 80. We subtract. We have 32 left over. A new array, because it's an open array. Now 8 times what? 8 times 4 is 32. We have 8 times a total of 14 is 112. And we can check that. I always have students, if you've introduced it, check that. So it's going to be, it is going to be 8 times our 14. And we just have the students check that. And it does check out. That is open arrays. Modeling. I love modeling. Wherever I can have students use their hands, use something in class, in real life to model, I will. And I love modeling. Might not be appropriate, especially when we get into such large values. But if I have another problem with 72 students, and chairs, so we have 72 chairs, and we want to put these students that are sitting in these 72 chairs into rows, and we want 12 per row, which is another good opportunity to introduce the word per for each. Sometimes as they get older, they know it means to multiply. 12 per row, and we could actually have the students start to model. Since I'm doing a row of 12, you might like to have them model it, or you model it with them, in groups of 4, because there ain't no 4 times 3, going back to arrays is 12. And as they start to do this, they might realize and pick up on some patterns, and that's exactly what you want. Ideally, they might even move from this and realize, making that model took a long time. What can be quicker? And you might want to introduce some other faster ways. And they might see, I have my 3 rows of 12. What does that add up to? And when they do the addition, they might see it's 36. They might know some multiplication facts, or even see some addition facts. I know that we do doubles. So they might know double 36 is 72, or just continue modeling. But again, I do enjoy modeling, and I think that's a good example of one. Moving them towards something like this would be quicker, but again, age appropriate. The last one is just an acronym. It's from year 6, and I really enjoy it a lot. And it involves long division. So if we are looking at long division, and I forget the steps, or I'm trying to explain to a student some of the steps, an acronym is often helpful. And year 6 has dad, mom, sister, brother. And I like it a lot. I just add a little twist to it that I've used and I've learned from them and tried to research, what do I do about that one problem where I divide? And let's say we're looking at 873 divided by 5. So 5 goes into our first value, our first digit that we see. 5 goes into 8 one time, 1 times 5. So there we're doing our division, 5 into 8. Now multiplying, so dad, mom, sister, brother. Divide, multiply, subtract, bring down. My multiply, 1 times 5 is 5. Subtract, bring down. But how do I let the student know that we're repeating? So I like another acronym is does McDonald's serve burgers where? And then that helps them hopefully remember the repeat. So when I get to this point, we're not done. We need to repeat. Go back to the top. Divide. 5 into 37. 5 times 7. 35. Subtract. I have my 2. I'm going to bring down my 3 because my burger, my B tells me to bring down, and then repeat. The rare 5 goes into 23 4 times. 4 times 5 is 20. We have nothing to divide anymore. 5 cannot go into 3. There's no more multiplying, subtracting. There's nothing to bring down. There's no repeating. This is our remainder of 3. So our answer would be 174 with a remainder of 3. I hope that helps. Please see me if you'd like to talk about any of these, or more importantly, if you have something that you'd like to share that you know works really well with your students. Thank you for watching.